here. So start. Could you confirm that you are seeing the presentation?
Yes.
Yes, good. So yes, so to you, we prepare a practical example that considers the life cycle of the olive oil. So, and I think you had the opportunity to see the life cycle stages, the proposal in the participants pack that was sent in the last week, and to think a little bit about what can be included in each stage of the life cycle and the inventory, the inputs and outputs that was Eduardo spoke in the theoretical part. So that's it. We can move forward. And yes, so we will analyze the life cycle of olive oil from the raw material production, that is, in this case, the olive fruit, to the end of life. So the whole life cycle will be included in the analysis. So we have the raw material production, the olive fruit, we have the extraction of the olive oil from the olives, and we have the packaging of the bottles, distribution, the use of the olive oil, and the end of life will be for treatment. That is, it's a process of purification of the used oil, and for example, to recover later on in recycling. But here, an important thing is the use will define the functional unit, because we consider, okay, we deep frying, for example, in an industrial kitchen, so we use 1 liter of olive oil for that purpose. Okay, and we have here some steps and materials that are included in each stages. This is the process that we model. And yes, we will we prepared an Excel that we'll share in a minute. So everybody can have access to that. And the Excel file is already filled in because it's to be more agile, and we can have time to maybe for the discussion part of the interpretation of the results that can be more interesting. But after the workshop session, you can maybe change some variables and parameters and see what are the different sources in the LCA results. So, and basically we will follow the steps of the LCA life cycle assessment methodology. So we'll define the goal and scope, that it's okay, the whole life cycle of olive oil. We'll develop the life cycle inventory. We have already a proposal for that. We'll calculate the environmental impacts based on that inventory, and we want to interpret the results. And the LCA is important not only for knowing calculating the impact of a product, but also to compare with other equivalent products for the same purpose, same applications. We choose 2 examples, the rapeseed oil and the palm oil, and also in an eco-design perspective, that is, so I can see what are the main categories or the main life cycle stages that have contribute more for the overall impact of olive oil, and so what can you do to improve that and minimize the impact? These are important steps and issues to analyze. Yes. So that is, we've talk about this. So it's to remind that it's a cradle to grave approach. The functional unit here, as I said, 1 liter of olive oil for deep frying. And yes, we want to compare the results that we will obtain for a comparison with other products and improvement purpose. Yes. So, yeah, and before we move to the next slides, I don't know if considering the life cycle stages that we showed to you, you want to maybe give some examples of what you think should be considered in these inputs and outputs categories that we have to see. Well, natural resources that are used from nature, from technological sphere, materials, fuels, water, energy also, and wastes and emissions that came from that process. So if anybody want to comment or give a suggestion from the olive production to the extraction and so on. If nobody wants to give a clue, we have all that set, but okay, it's just to hear your voices and some more interaction, but okay. We have here it prepared. So for the olive production, the olive fruit production, yes, we have here. This is more to show different perspectives of inputs and outputs that we can consider. And we have here two that are from the natural resources. So as you know, always we have, anytime we have a tree culture or plant culture, we can capture carbon dioxide from air. So and it can retain, so it's a good thing for the environment. But we also have occupation of lands. So these two are part of the natural resources. And then we have the technological spheres. So yes, we know that we have to have fertilizers for the productivity grow, also application of protection products, some irrigation if the rain is not enough, and also machinery and transportation for all the steps, and also to transport the olives to the extraction mill. And also we also have some outputs that comes from the use of fertilizers, the machinery, agricultural machinery, and of course, if we are using the olives and we're taking, we can have some waste wood from the mushing and other equivalent operations. And we'll have this all set up in the Excel, but it's just okay to show you here better. So. Oh, sorry. Since I'm talking, I'm not seeing your hands, but you can interrupt if you want to. Okay. Não estou a ver porque tenho a moda apresentação.
Okay, just Etienne posted a question in the chat. So he's asking if the carbon dioxide inventory, if that is being measured or if that is from a database.
Database, yes.
Yes.
We can. Desligar o microfone. Yes, we in this case we have the process set up in the database of CIMAPRO, so we could take that data from that. Yes, but yes, if you don't need it, we could check in literature review or maybe some experimental measure to see. But yes, we have the data from database. Okay, so in the inventory before, the previous inventory for olive production, it will have some impact here because to produce 1 liter of olive oil, we'll need 5.22 kilograms of olives. So we multiply for that value. And you will also need some water for washing, and propane, electricity, hexane is as a solvent agent. Okay, we are considering here the conventional mix that we have in Portugal, for example. And we also have outputs and emissions, and besides the emissions, we have wastewater from the vegetable refinery and bio-waste, that is the olive pomace. And in this case, we are considering that bio-waste will be treated by industrial composting. And these are reference values. We can move to the packaging and distribution. This is a simplified model. So we have PET bottle grade for the bottles of 1 liter, and also cardboard box to pack the many bottles. And then we have distribution by lorry. And we have the considered emissions inside this process of the databases. Yeah, here the last stages, that is the use. We'll use heat because of gas ovens and gas stove, and we have our main final product and output is the used vegetable oil that will go to a treatment process that also have some consumables and electricity too. So we have the yes.
So just Ken is just asking why have we not considered if we have considered the transportation of the harvest of the olive from the olive trees to the processing plant.
I think that is considering inside the agricultural machinery and transportation. I can go up here because we have this value. Say ton kilometers divided by the functional unit. And so imagine this is a farm that also have the production and also just a few meters, few kilometers have all the extraction mill, because that happens a lot in Portugal, for example. The olives are close to the places there they will be harvested and then go to the extraction mill. It's not really far away, but we have that examples. Yes. So we can now move on to the Excel file and we'll share it first with you. Okay, so this is the file that we are hoping to share with you. If it's not working by Teams, later on we send by email for all of you. So we have here what we'll have talking about. The system in analysis, each stage inside the borders, the functional unit, and the considered impact categories. We'll choose this among the whole bunch of categories that you see in the theoretical part. So it's the global warming potential, the terrestrial ecotoxicity, mineral resource scarcity, and water consumption.
Anna, sorry, just a
Yes.
question. This Excel file, so it's a normal Excel file that you use for all the cases, or it's just an adapted one to this specific case?
It is usually we can have use the Excel file adapted to several LCA studies, but we get the information from CIMA-Pro. So we model there the process, we get the results, the emissions factors, and then we can copy, export and copy that from the Excel file. So the use cases, each one, the three, we will also work based on the Excel file like this. Okay, that's it.
Thank you.
Yes, so we have here, so by lifecycle staging and by category of inputs and outputs, we have here fill the values that was shown in the presentation. Okay. So the green one here signed are the ones that we could get the emission factors from CIMA-Pro, and if you want to make some change here, the Excel is prepared to make the calculations, and you are able to see the difference in LCA results in the next page that I will show. And it is based, well, you can find here the emission factors for the process and then the environmental impacts considering the value input that we used. Okay. So that is, now you're seeing now the presentation. I hope so, because we are switching from one file to the another. So after the inventory analysis, we have the impact assessment. And yes, that we will see the results and we use two methods, the midpoint and the endpoint. So we'll have for the problem-oriented, you have these four impact categories. You have the characterization and then the normalization results. And we also have the inputs is the damage-oriented, that is human health, ecosystem, and resources. Also in a normalization based that you were able to see in the theoretical part. Okay. So we collected our inventory, modeled the process, we get the calculations, and yes, what do we get? Okay. So this is the characterization method. So we have here the global warming potential, terrestrial ecotoxicity. Okay, the mineral resource scarcity is here not a big weight, and the water consumption. And here EFD unit, so it's CO2 equivalent. So all the inputs have some weight in the CO2. The equivalence is the dichlorobenzene, is a measure of, because it's a product used in pesticides, so is a measure of ecotoxicity. And we have the Q per equivalent also because the mineral resource scarcity is measured in this way. So what Q per equivalent has to be used to process the olive oil, and water consumption was more simple, as cubic meter. So then we have the normalization results. Okay, so remember what we want to analyze and the information that we want to see. Looking to this, what are the impact categories, the main impact categories that have biggest weight in the olive oil impact? So we have the water consumption and terrestrial ecotoxicity, and of course there are always room to improve global warming, but these two, okay, presents the main. And this is just for 1 liter. And here in normalization endpoint, we have, okay, this is the distribution related. So the human health is also a major weight relating to ecosystems and resources. So this is the overall impact. Then we can divide the results by stages of the life cycle. It's an interesting analysis. So, okay, we have here that for our main impact categories, that here in blue we have the olive production stage, and the other one that is the second biggest is the olive oil extraction. So these are the two main stages that have contribute most for the impact of olive oil. For global warming is the olive oil extraction that contributes the most. And we also have here for the endpoint categories, it continues to be the olive production stage and also the olive oil extraction. Okay, why does this happen? What can be the reasons? Okay, so in olive production, we are using a lot of fertilizers and other products, pesticides. In the olive oil extraction, we have the energy from electricity, propane, and also a big issue is because we have wastes, considerable amount of waste that has to be treated, and it has impact in the land that they use for the treatment, and the remnants and residues that can be freed from that waste. So here, then you have a table that just show a little better the percentage of the contribution of each stage, sorry. Yes, we can see that the olive production have the biggest impact here, and then the extraction in global warming. Okay. So this is our results. And now comparing with other cooking oils, with palm oil and rapeseed oil. Okay. Well, global warming, okay, we are already not bad, but also room to improve. Terrestrial ecotoxicity, we can do some improves to reduce, because it's okay. It's not the biggest well or the major, but it's close. In water consumption, well, in our inventory, what we consider here is only a relative approach. Yes, it has a more impact related to the other two, but in the endpoint perspective analysis, okay, we are in the middle. So we have here some room for improvements. So if we have room for improvements, we can think what we can change in the inventory in order to get this environmental improvement. So yes, after we identify what we want to identify, okay, so this is our proposal for the change in variables of the process to improve. So we have the production stages, and okay, in a realistic perspective, can we reduce 30% in fertilizer and also in plant protection products, so pesticides, and also 50% in irrigation. And then in the olive oil extraction stage, we can change, instead of a conventional mix, 100% renewable sources, in this case photovoltaic, because it will be in the south, so it will be very sunny, very hot, to be efficient. And also the bio-waste, we will not send to treatment, we will recover it and move totals 100% for ethanol production. What does this mean? We are avoiding raw material or a virgin material for ethanol production, because our bio-wastes can be used in that process instead of maize for virgin production. So yes, and this is another thing that can be modeled in LCA is the avoided products because of circular economy. Okay. So yes, we change. So it changes for these values. It's okay. So that is the amount of electricity is the same, but the source is different, and we have now 0 kilos of bio-waste for industrial composting, and we have the calculation in Excel, because it's the conversion that we can get from 3.33 kilos of bio-waste, what you can get from ethanol, and this 0.25. Okay. So you have here what is in blue, what's changing. Now we have this field divided products, and we can see after the calculations what we can improve. So what happened? Okay, now this is only normalization, midpoint and endpoint. What could we get? Okay, so global warming, yes, it get lower. Mineral resources is here doesn't contribute a lot, so the values are residuals. Terrestrial ecotoxicity, yes, it's also a reduction. And remember always that we are considered a liter, but if it is a industrial production units or million tons or million liters a year, it can be significant. But water consumption did not decrease it. By the other hand, it raised a little bit. However, in an endpoint perspective, so damage, the changes were good because the overall impact decreases. Okay. And we can here we have the conventional scenario per se and the improvement scenario. Also by the categories and by life cycle stages, which are the most contributions. So okay. The olive production here and the oil extraction reduced a little bit, but in water consumption, okay, the 50% decrease in irrigation was good, but something happened here in olive oil extraction that causes this raising in water consumption. And we have also the same distribution here for the endpoint categories. Here in ecosystems, we don't have a lot of changes, but we have it in human health. And then you can see once this water consumption issue is in olive oil extraction, okay, what we could do is in Simapron see the emissions factors for the specific variables that we made in this stage. So we have the impact for total extraction stage, the conversion and the improvement scenario. We have one scenario with pomace by waste for treatment, the other one with ethanol substitution, is the gray one, and we have the impact of the electricity. So here in global warming, okay, we go to negative values in the improvement scenario just because mainly because of this question of circular economy. So it's really important to valorize residues and wastes and not, if we can use it in other process, not search for virgin materials. So it's a good thing. Also for terrestrial ecotoxicity and mineral resources. But okay, what the results say to us is that the electricity here from the conventional mix to photovoltaic 100% causes an here water consumption goes a little higher. Okay, this is why. Well, photovoltaic, yes, it's renewable, but it can use a lot of water in the use and maintenance stage. So, and we are not here to claim anything about any source of energy or the other projects, just to give you the different analysis perspectives and not only looking to global warming but other impact categories, because it's interesting. We could improve in 3 categories, but is one that's okay, we do not get the result that we are expecting for. So also you also have here the table that show the reduction in the overall olive oil impacts, and then by production in a second stage. So you have here global warming decreases 62% is good. We have but then an increase of 21% in water consumption. So, and we just left here some considerations and final conclusions. That is, okay, maybe we have to think in the inventory, we have to think in other strategies to don't have this increase in water consumption impact. So maybe recirculation strategies, so use the water several times to do these maintenance and cleaning stages, or other strategies that they can be in the probably already defined in the literature to overcome this challenge. But it is, we could decrease the impacts with the changes that we made in the improvement inventory, but it's always important to consider all life cycle stages, different impact categories, and yeah, circular economy and the recirculation strategies. So that is here the example. So the next step is to share with you. I don't know if you already were able, but in the final of the session we will have this Excel tool, so you can use it for work materials, just to change some process to curiosity. Okay, so basically that was what a practical example that you want to show to you. And now if you have some questions, please bring it on, and we can discuss more.
Anna, there is a question in the chat from Tian.
Yeah.
I don't know if you are able to see. Yeah.
I think now I can see all the questions.
Yeah, the last one.
Yeah. Okay, that's it's as I what was talking about is, is because of that the cleaning maintenance stage of photovoltaic panels require a lot of water. So
So what I
wait a
think
minute, yes.
basically my question
What
is
issue
that
this?
you have the scenario where you do improvement, right?
Correct,
But then
yeah.
every time we do an improvement, there is different aspects of it, whether there is in terms of the water, the energy, the greenhouse emission, etc., etc. But then in the case where you just shown, not each of the elements actually show an improvement, right? Some has a positive improvement, some is negative. So then how do you then decide I mean, obviously in an ideal scenario, if you have an improvement where you have all of the different elements are positive, then okay, that is a clear winner. But in this case where you have some is positive, some is negative, so how would you make a decision on which one is the best, or yeah,
Yes.
if you know what I mean?
I think yes, it's the normalization step is important to see if the impact category still remains same level compared to others or not. The endpoint show that in the overall, okay, it decreases, and the endpoint considering all the impact categories, not only the 4 that we show they're specific. And that's it. Is that it's if you gain some improvements in several categories and you can analyze more. We only show 4. You'll see, yes, that is if it impacts in the ones that have the major weight or not. And yeah, it is to think about in strategies to overcome that challenges. But it's always a interesting discussion, and it's not black and white. So
If I can add, the question Tian is making is the question that every LCA practitioner has when using the tool and then trying to use the tool for improvement. Because in fact, the environmental performance assessment, because it has so many different categories, and it's almost impossible to connect them in a way that um, it's very rigorous with what happens really in a reality. So in environmental systems, it ends up being a trade-off exercise. So we have to look at the benefits coming from a given change to the product system, see how it improves or it worsens the performance in the given impact categories, and then see if we want to stick with those changes and get the benefits in given impact categories, and also take the worsens in other impact categories, or if we want to stick with the original, because it's very rarely that we have changes in product systems that are beneficial across the entire span of categories. So eventually it's a decision between the team of engineers and the team of environmental specialists, and ultimately the product manager, or to see how much it costs as well, because we are only discussing this from the environmental perspective, but of course the economical perspective has a big weight on it as well. But it's a discussion. It's an input for the decision making process, and sometimes it's the conclusion is that what we are improving is not sufficient with what we are worsening, or vice versa, and the changes end up not happening. Or we try basically to see if we can have maybe some minor changes that get improvements and don't get worsen in some other categories. So it's really a trade-off exercise, and it's hardly an easy decision where we only have benefits, unless you have like efficiency gains. If we reduce the amount of energy that is necessary, or if we reduce the amount of material that is necessary, or if we use more recycled material, and all of that, that is usually beneficial across the different environmental impact categories. If we do changes from one process to the other, but we don't improve the amount of process that we use, so the amount of energy or the amount of material, so we just change from one material to the other one, maybe we get some improvements in one category and not so much improvements in others. So it really is a trade-off situation. So yeah, I think we have also a question from Diogo. You're mute here.
Okay, thank you. Thank you for your presentations and for your nice work. Just one curiosity that perhaps you could, I don't know if you have considered, if not, I will recommend you to enrich the example with that. Have you considered the difference between making the olive harvest by workers by hand and versus the machine? Because I know that for producers, that is a main issue, because it has, as Eduardo was saying, has the economic impact, but also as usually they consider the economic impact of buying the machine versus buying the workers, but also for the trees, for the destruction that the machine can have by destructing part of the tree. So I think if you also consider for that, for the environmental impact will be also an additional dimension that you can give to this example, and also to give as I would say as an outcome for generalized process, that it's not only the economic impact, not only the I would say and the other dimension, but also the environmental dimension that people are not used to have it. So yeah, so do you have any consideration and how that will change your LCA analysis in that sense?
Okay, so well, that is a very good question, because in fact is the traditional way we olive oil was extracted from the and removed from the olive oils, where olive fruits were removed from the trees. So beginning by answering the LCA study is not sufficiently. So we use mostly software and databases, and this is actually one of the limitations that we are going to address within the Syntecs project, because there is a very big lack of databases and information on the processes related with the laser machining processes and those associated with the case studies that we will be addressing. So that is also one of the objectives of the work within the project, is of course to develop this database. So, but apart from that, we on the olive trees, the LCA is not fine enough to get the details of any changes to the tree health or longevity of the tree coming from the mechanical extraction, from manual extraction. So that we cannot incorporate in the analysis. We have not the data to be able to incorporate that in the analysis. It doesn't mean that if we have the data, we can in fact incorporate that in the analysis. On the other issue of the more broad issue of we considering that suggestion, I think it's very interesting, and we can do that really to see. That comes to it should be more healthy for the trees, but it should have an effect on the efficiency. So we'll take more time, but maybe time, maybe money. But in this case, time for the environmental assessment, it may not be visible. So the increase in cost may not have a visibility in our indicators. So from the environmental perspective, it will probably be an improvement. Now the issue would be, if we look at year long, the amount of olive oil that we can extract from a given area in 1 year will be the same if we do it mechanically or manually, of course, because there is crop times. But if it was like a 24-hour continuous process, there would be a big effect on the efficiency. So we would take less olives from the same time, or we need thousands of people collecting, which I don't think would be the comparable case. And in that case, it would of course affect the productivity, and will of course, affect also the environmental impact. Because for us to get 1 liter of olive oil, we could take this, for instance, in 1 year using mechanically, but we can, if we do it manually, we could only do it not the same amount. So the proportionality would have to be comparing half liter taken from manual with 1 liter taken from mechanical. But I think it's an interesting scenario. We can take this in consideration to see really in terms of environmental performance, how does it compare to have the mechanical extraction from the manual extraction.